1, roots and radical expressions. So these are our properties of our exponents. So let's go over them real quick. If I have a raised to the 0 power, and a in our case is any number, okay? So any number raised to the 0 power is always going to give me 1. 5 raised to the 0 power is going to be 1. 4 raised to the 0 power is going to be 1 raised to the 0 power is going to be 5,622 raised to the 0 power is going to be always. Got that? A raised to the m over n. If I have a fraction as an exponent, I'm going to take them and I'm going to subtract them. So it'd be a m minus n. A raised to the negative n. Anytime I have a number with a negative exponent, I can't have negative exponents. So I need to make it positive. So that means wherever it's at, it's going to go on the other side of the fraction bar. So if I have a raised to the negative n, it becomes 1 over a raised to the n. Well, what if I have 1 over a raised to the negative n? It becomes a to the n over 1. It just flips to whatever side, to the opposite side. Does everybody get that? Okay. This one right here, a and b is parentheses, and I'm raising them both to the n power. So it's kind of like distributing that n out to the exponent spot. So I'm going to raise a to the n power, and I'm going to raise b to the n power. So I have a to the n times b to the n. Up here, I have a to the m raised to the n. So I have a power raised to another power. That means that I'm going to take my two exponents, and I'm going to multiply them together. And then I have a to the m times a to the n. So if I'm multiplying them, I'm going to add them. And then this one down here, I'm dividing a by b, or a divided by b, and I'm raising it to the n. Well, this one's kind of the same thing as this one down here. It's kind of like taking the exponent and distributing it to this power and this power. So I have a to the n over b to the n. It's very important that you know these exponent rules. They're going to come in handy, okay? So star them, circle them, whatever you have to do. You need to know these. You're going to refer back to them and keep referring back to them, so you might as well just memorize. So let's look at some problems. So my first problem reads 5a cubed times negative 3 a raised to the negative 4. So what my problem is telling me is that I'm going to take the first term, 5a cubed, and I'm going to multiply by the second term, negative 3a to the 4th. So let's get the coefficients out of the way first. 5 times negative 3 gives me negative 15, okay? So now the only thing I have left over is a to the 3rd times a to the negative 4th. Well, what do I do with my exponents if I'm multiplying them together? You add them, right? So 3 plus negative 4 gives me a raised to the negative 1. Can I have a negative exponent? No. What do I have to do to make it positive? Flip it. Put it on whatever other side. So this would be negative 15 over a, or a raised to the 1, however you want to write it. I usually don't put the 1 there. So my answer for this would be negative 15 over a. The second one, negative 4 times x raised to the negative 3rd times y raised to the 5th. And I'm going to take all of that because it's all in parentheses, and I'm going to raise it to the 2, to the second power. So what do I need to do with this 2? Kind of like distributing it out. So it's going to be negative 4 raised to the second power, x to the negative 3rd raised to the second power, and y to the 5th raised to the second power. So what's negative 4 squared? 16. What is x to the negative 3rd to the second? What do I do when I have a power raised to another power? You multiply them. So what's negative 3 times 2? have y to the fifth raised to the second. So what's 5 times 2? Is this my answer? What's wrong with it? I have a negative exponent. I can't have a negative exponent, so that means I've got to move something around. What's going to be moved? That's going to stay on top. What goes to the bottom? X to the 6. You see how you have to have some knowledge of these exponent rules to work these problems? Learn them. And the bottom problem down here. 4ab to the 6th, c to the 3rd, divided by a to the 5th, b to the 1st, c to the 3rd. So always look at your coefficients first, and let's get rid of them, your numbers. Okay? So this right here would be 4 over what? Basically 1. So I know that 4 is just going to be taken over. Done with that one. So now let's look at our a's. I have a to the 1st divided by a to the 5th. When I'm dividing exponents, what do I do with them? You subtract them. So 1 minus 5 gives me negative 4. Well, if it's a negative exponent, it has to go where? B to the 6th over b to the 1. So 6 minus 1 gives me, and then c3 divided by c3 gives me, so that right there would be my answer. Okay, 2x to the 4th divided by 3 raised to the 3rd. 2x to the 4th divided by 3 raised to the 3rd. 2x to the 4th divided by 3 raised to the 3rd. So what am I going to do with my 3? I'm going to take it and I'm going to move it here, I'm going to here, and here. Don't forget, you got to do it on bottom too. So I have 2 to the 3rd times x to the 4th to the 3rd divided by 3 to the 3rd. Has to go everywhere. So what is 2 to the 3rd? 8. What's x to the 4th to the 3rd? X to the 12th. Remember, I have to multiply them if I'm raising a power to a power. And then over 3 to the 3rd would be 27. Now, I'm going to stop right there and look at it to see if there's anything that I can reduce. Can I reduce 8 over 27 in any way? No. So my answer would be 8x 12th over 27. Just make sure you always look to see if you can reduce it, though, okay? 2 to the 3rd, 2 times 2 times 2 gives me, you wanted to say 60.
Yeah.
Because you said 2 times 3. It's not saying 2 times 3, it's saying 2 times 2 times 2. Okay, 2x to the 3rd, y to the 7th. I'm going to take all of it and raise it to the negative 2. So what am I going to do with that negative 2? Is it up there? Was it up there?
Mm-hmm.
So 2 raised to the negative 2. X to the 3rd raised to the negative 2, y to the 7th raised to the negative 2. So what's 2 raised to the negative 2? Y'all think? 0.25, which in fraction form, because we don't deal with decimals, 1/4. So we we got that out of the way. So x to the third raised to the negative 2 gives us x to the negative 6, because when I'm raising a power to a power, what do I do to them? Multiply them. So 3 times negative 2 gives me, so that's going to go on top or bottom? Bottom. And you would not put negative 6. You would put 6 because we're making it positive. Okay? And then y to the 7th raised to the negative 2. Y to the 14th, and it would go on the, there's my answer. The last one says h to the 7th, k to the 3rd. I'm taking the whole thing and I'm raising it to 0. What is my answer? 1. Correct. Those should be the easiest ones there are, and you should never miss them.
Where'd you get 1 from?
Because 2 raised to the negative 2 gives me 1/4. Everybody got these? We're good? Okay, Skylar. Okay, this one. 6x to the 3rd raised to the 0 divided by 3x y squared. 6x to the 3rd raised to the 0 divided by 3x y squared. Yes, what's your question?
Where'd you get the 18? I'm just wondering. Where'd you get the 18?
From this one down here?
Yes, ma'am.
That was my problem. H to the 7th, k to the 3rd raised to the 0.
Oh,
It's going to give me, yeah, that was the problem. Okay, so 6x to the 3rd raised to the 0 is going to give me what? 1. 1? Is there anything that I can do to this? No, so I'm just going to copy it. And there's my answer. So all I've been doing is just reducing these exponents, okay? Using our properties of exponents.
So you're going to add something.
Not really. It's different, but not any harder. So I have 4a to the 8th divided by 2a to the 4th. What am I going to do first?
Your coefficients.
Your coefficients. 4 divided by 2 gives me 2. Now I have a to the 8th divided by a to the 4th. If I'm dividing, what do I do with my exponents? Subtract. So 8 minus 4 would be
4.
So the bottom one says s to the 4th times t. I'm going to raise all that to the 2nd power, and then I'm going to multiply s times t. So what am I going to do with my 2 right here? Kind of like distributing it out. So that, and then that. So I have s to the 4th raised to the 2nd, t raised to the 2nd, times s times t. So this, s to the 4th raised to the 2nd becomes s to the 8th. T raised to the 2nd just becomes t squared. And then I have an s and I have a t. Well, what do I know about these right here? They're ones, right? Anytime I am multiplying like terms together that have exponents, what do I do with the exponents? Add them. So 8 plus 1 would be 2 plus 1 would be, and that's my answer. Okay, last one like this. Are you done? Just throw it on my desk up there at the top. Thank you. So 1 over h raised to the negative 2. I'm going to raise all that to the negative 1 power. And then we're going to times it by h raised to the 3rd. So we need to deal with this right here first. Okay? Because I know that's not going to change just yet. So I have a negative exponent raised to a negative power. I can't have a negative exponent. So what does that mean I'm going to do? All I'm going to do is switch it. Because
Okay, I got it.
it's going to become like that, correct? I'm just leaving that part out. So now my problem reads h to the 2nd times h to the 3rd. Yes,
I
ma'am?
need John Spencer for checkout.
Okay. H to the 2nd times h to the 3rd is going to leave me with h to the 5th. Because if I multiply exponents, I add them. John, don't forget.